Now let us see the common tangents that can be drawn to a pair of circles. Now the first type of the common tangents are called as the direct common tangents, and by the word direct it means that both the circles are on the same side of that particular common tangent. So here we can sense that one tangent can be drawn like this and the second tangent can be drawn like this, isn't it? So these are the two direct common tangents. First of all, common tangent means the same line has to touch both the circles simultaneously, and by the word direct it means both the circles must be on the same side of the tangent. Now here suppose we want to find out what is the length of that particular segment which is common to both of them. So let us call that as say L. Right? Now how to find the length L? That is the question that we are trying to address. Right. Let us draw the respective radii. Let us call the bigger radius as R1 and smaller radius as R2. Let C1 and C2 be the two centers. Okay. Now we do a small construction, that is we drop a perpendicular from the center of the smaller circle on the radius of the bigger circle. Right. So this is that particular perpendicular. So we agree that this is 90 degrees, right? And if we join the two centers, then you see that we get a right angle triangle, and let us name the point as say P here. So therefore angle C1P C2 is 90 degrees, right? And we can see that the distance PC2 is also nothing but L. And what is the distance PC1? That is nothing but the difference of the radii from the figure. And hence using the Pythagoras theorem we can say that C1 C2 square must be equal to L square plus R1 minus R2 the whole square. So therefore we get L as square root of C1 C2 the whole square minus R1 minus R2 the whole square. So that's the expression that we get for the length of the external or the direct common tangent. Now there is another possibility also, that is something called as a transverse common tangent. So that means a tangent can go in such a way that the two circles are on the opposite sides of that particular tangent. So this is one transverse common tangent, and there will be another transverse common tangent here also, right? So now for the sake of derivation let us show only one transverse common tangent, and suppose we want to know what is the length of the common segment that is trapped between the two circles on the tangent. Okay. So here also let us drop the perpendiculars from the respective centers, say C1 C2 on the tangent. Let the radii be R1 and R2. Let the points of contact be shown as P and Q. Now here what do we do is we extend the radius C1P, and on that from C2 we drop a perpendicular like earlier. Okay. And also let us join the two centers of the circles. Let us call the point where the perpendicular from C2 meets the extended C1P as point M. So therefore now we see that triangle C1 MC2 is a right angle. So therefore angle C1 MC2 is a right angle. And if you observe, this length PM is nothing but R2 only. Correct. So therefore the length of side C1M turns out to be nothing but R1 plus R2, will be the sum of two radii. And hence in triangle C1M C2, if we apply Pythagoras theorem, we get C1 C2 the whole square is equal to M C2 square plus M C1 square. Now MC2, this length is nothing but the length PQ because that's a rectangle, so clearly MC2 is nothing but L, so we have L square plus MC1 is nothing but R1 plus R2 the whole square, and that is equal to C1 C2 square. So therefore at the end we get the formula as L is equal to root of C1 C2 the whole square minus R1 plus R2 the whole square. So of course, while using this formula, it is assumed that the expression inside the square root is positive only, because otherwise the square root will not be possible. Correct? Now let us see the number of transverse and direct common tangents that can be drawn to a system of circles. So as we have seen these 6 different possibilities in a system of 2 circles, let us first draw the direct common tangents, so that I will show in green color. So when the 2 circles are completely separated, right, so we can draw the 2 direct common tangents like this. Even if they are touching each other externally, still we can draw 2 direct common tangents. When they are intersecting, in that case also we can draw 2 common tangents, as we can see here. Now in the 4th case, when they are touching internally, we can draw only 1 direct common tangent, you see. That's the only possibility where we have a direct common tangent. In the 5th and 6th case, it is not possible to draw any direct common tangent. Now let us come to the transverse common tangents. So in the first case, once again, when the 2 circles are totally separate, we can draw 2 transverse common tangents like this, right? When the circles are touching each other externally, we can draw only 1 transverse common tangent, and in the all of the remaining 4 cases we cannot draw any transverse common tangent. So this is how the different possibilities arise in case of a system of 2 circles and their tangents.